All right, trains are cool. Floating is cool. Floating trains are even cooler. Today I'm going to talk about maglev trains and how they work. And at the end of the video, I'm going to get to why maybe there are more of them. Maglev trains work on 4 principles: levitation, how they stay up off the ground; propulsion, how they keep moving once they're off the ground; guidance, how they stay on the track and don't topple over; and power, which is just how they get their power. Levitation is how maglev trains stay off the ground. This is achieved through like-poled magnets on the base of the train and on the ground. Now these like-pole magnets are just like, you can think of them as normal fridge magnets, right? That if you hold the like sides together, they repel off of each other. This is achieved, one way this is achieved is through coils with superconducting magnets. These coils are cylindrically wrapped around to produce a magnetic field going, you can think of it going this way, and supercooled magnets, who also similarly are going this way, so they repel, right? And so these supercooling magnets are down at temperatures of like around 0 Kelvin. That's almost absolute zero. And then they can superconduct, right? Which makes these ordinary magnets that normally wouldn't be able to hold these trains up. And that allows them to hold these trains up to heights about like 3 inches. Okay. This method is incredibly expensive because it's incredibly expensive to supercool these magnets. The other way is a Hallback array, right? Which uses this specific arrangement of magnets repeating on like for a few times, right? On the base of the setup, to create a magnetic field that is stronger on this end and incredibly weak on this end, because you only need one end of this magnetic interaction to be strong. And that way it is a little bit cheaper than these superconducting magnets, but still expensive because of the complicated arrangement of these magnets, which needs to be ultra precise. Another way that this is done sometimes in slower trains is a typical electromagnet, but this way tends to be weaker and only used then for trains that aren't going the typical bullet speeds that you hear about when you talk about maglev trains. Next, we'll talk about propulsion. Propulsion is how these maglev trains move across the track, and it's created through a push-pull interaction between the train and the guideway, or the track. Now, the train itself has these stators, which is these little metal pieces that have these teeth that have coiled wire around them. This coiled wire is supplied with an alternating current, which creates this magnetic flux along the gap between the train and the guideway. Now, in the guideway itself, there's this translator, right? And this translator is always supplied with an electric field. But this translator is also sometimes paired with magnets to strengthen the effects. Though sometimes people are looking in how to cheapen the process by removing these magnets, expensive magnets, from the top. These magnets in this translator are supplied with a direct current. This direct current creates a flux in the space as well. But this direct current, the flux between the translator and the flux between the stator, create this kind of locking relationship, which is what propels the train through a push-pull interaction, which is kind of depicted here, right? You can think of it as the North Pole at the front of the train and the South Pole at the bottom, repelling each other, just barely overlap. So the train is being pushed this way and then pushed again when the South Pole reaches the North Pole here. Maglev trains are guided by magnetized side rails and coil magnets on the train. These coil magnets and magnetized side rails are varying in strength, so they can be pushed one way or pulled another way. These side rails are on either side of the train, and so it can create a balancing effect, almost like you're on a balance beam. These maglev trains need an immense amount of power. This power is supplied generally through electromagnetic inductive transfer, which sounds complicated, but it's the same principle behind induction stoves and in the wireless charger in your iPhone. There are currently 6 maglev trains in operation around the world, most of them being based in Japan or China, with a 7th maglev train being constructed between Tokyo and Osaka. The reason for this scarcity is generally described as the cost. A U.S. Department of Transportation Federal Railroad Administration study from 2005 estimated the cost per mile to be $99 million. Despite this immense cost, maglev trains remain the fastest and the most energy efficient technology on the market. Thank you for watching, and I hope you enjoyed the video.